Hi, Susan.
Hey, Christina.
Let's finish up this hypothesis testing unit, yeah?
Oh, let's do that. We're going to do hypothesis test on means, aren't we?
Right, means.
Okay.
Where we're testing a claim about a mu, right?
About a population mean. Okay.
Good. All right, so first of all, let's look at the technology that we're going to use, okay? We're going to use t-stats, one sample, either with summary or with data, just like when we were doing confidence intervals for means.
Okay.
So, when you put your information in, you can also show critical value, just like we did with proportions.
Okay.
And just remember that's going to be a t, though. Okay.
Exactly.
Right.
Yes.
But we'll enter our sample mean, sample standard deviation, sample size. Okay, that information will be either given to us or if we do with data, then instead of doing that, we'll just select what column our data is in.
Okay, and when we enter that sample size, you know, when we were looking at finding critical values, T critical values, we had to use the degrees of freedom. We're not going to have to do that, are we? If we're telling StatCrunch to find the critical value,
Right.
Because StatCrunch knows how to find the degrees of freedom.
Yes.
All we got to tell StatCrunch is what the sample size was, and it will behind the scenes do that subtracting one. So we're reporting the exact sample size.
Yeah.
Okay.
Yeah, thank you for pointing that out. Definitely. And then, we'll perform the hypothesis test for mu. Make sure that you enter the correct values and symbols for the null and alternate hypotheses.
Oh, yeah.
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 Okay. Good. So, just a reminder that the formula for the test statistic, gives you a t-value. But we can get that from StatCrunch. It's called the t-stat.
Yes.
Okay. All right, so just like when we were doing proportions, we can use a test statistic or a p-value
To make our decision about the null. Okay.
Right. So just a reminder, if the test statistic, I'm just going to put TS for test statistic, is in the critical region.
And that test statistic in this case would be the z-score for our sample mean.
The t-score.
I'm sorry, t-score.
Yeah.
Said it wrong while I was sitting here. The t-score for our sample mean. Yes.
Yeah. Right. So let's do an example.
Let's do it.
All right. All right, so the EPA reports the exhaust emissions for a certain car model has a normal distribution with a mean of 1.45 grams of nitrous oxide per mile. The car manufacturer claims their new process reduces the mean level of exhaust emitted for this car model. A random sample of 28 cars is taken, and the mean level of exhaust emitted for this sample is 1.21 grams with a standard deviation of 0.4. All right, so where it says that they claim...
this is a sneaky kind of embedded claim in there, isn't it? Yeah.
Yeah, they claim that they reduce the level. So that's going to make our claim...
That it's actually less than it was before, which would be that mu is less than 1.145.
Yeah.
Okay.
So the other information I have here, I have a random sample of 28 cars. So that means N equals 28.
Okay.
Okay. That sample has a mean exhaust of 1.21. So that is our sample mean. Okay. And then the sample standard deviation is 0.4.
Okay.
Okay. So that claim mean is less than 1.45. That means our alternate hypothesis is the claim.
Okay. And we're doing less than, so that's going to be a left tail test. Okay.
Yep. And so the next thing I'm going to do, because I can get my degrees of freedom.
There's Christina's alarm that it's time to go to class.
So my degrees of freedom are going to be n minus 1. So
Yeah.
27.
But we are not going to need that
Right.
since StatCrunch now finds this critical value for us.
Right.
Yeah.
So I just need to make sure that I enter my information correctly here, right? My sample information goes on the top,
Okay.
right? That's for my sample data.
Okay.
And then I need to put my hypotheses in.
And that's based on the claim.
Mm-hmm.
So you're not going to be using the sample mean. You're going to be using that claim of 1.45
Right. And then I want to make sure I show critical value.
and set the significance
Right.
to equal alpha.
Alpha.
Okay.
Good. Okay. So when we do that, I'm going to get a critical value of negative 1.703.
And I was expecting a negative critical value because it's a left tail test.
Yeah.
So I was expecting to be down there below average.
Yep.
Okay.
Okay. So in our results, let's circle the important information. Okay. I've got my test statistic. That's my t-stat. I've got my critical value. That is my, here I'm going to put T's with these because these
Oh,
are,
that's good. Yeah. Since
are
I said Z earlier.
that's okay.
Yeah.
That's okay. So you can see these are both T's. That's what we're comparing to each other if we're using the test statistic.
Yes.
And then the p-value is a probability, so we compare that to alpha.
Can we just write our alpha right down below it so that we have all the stuff that we're comparing right there together?
Yep.
Okay.
Yep. Okay. So, you know, if I draw this out, that test statistic is definitely less than that critical value.
I think we have the output
Yeah.
bell curve.
Yeah, there is. It is right here. Yep. So the test statistic is here. I
That's
think.
that's our sample t-score.
Yep.
Yeah.
Yep. And all of this area beyond the critical value
Is our rejection region.
is the rejection region.
Yeah. And that's 0.05 because that's what alpha was, right?
Yeah.
Okay.
Yep. So I'm going to reject the null hypothesis because my p-value is less than 0.05.
Can we mark that p-value in just maybe a different color just to kind of remind people what the p-value is? We've got the alpha there,
Yeah.
0.05. The p-value is the area past our test statistic. So it's just that little bitty area to the left of the test statistic.
Yeah, that's my p-value.
So it's definitely less than alpha.
Right.
Okay.
Right. Because the alpha is this area including that.
Yeah.
That's beyond my critical value.
Okay.
Good. Okay, so the p-value is definitely less than alpha.
Yeah. 'Cause it's-
Okay, and then also my test statistic is in the critical region.
And both of those will cause us, either of those would cause us to reject the null. And so we're rejecting the null.
Yep. So since my alternate hypothesis was my claim, and I rejected the null hypothesis,
Look at that table right now that's in your formula sheet and make sure you know how to make this statement about the claim.
right, I would say there is sufficient evidence to support the manufacturer's claim that the new process reduces the mean level of exhaust.
Okay.
Okay. All right. So, on the next question,
How about the next? Do we have one with data?
do
I think we do.
we have enough data? Let's see. This one does not have data. Changing a tire. So try this changing a tire question on your own. And, you know, it says to use the p-value, but do it both ways. Use the p-value and use the test statistic.
Yeah.
And make sure that you can get the same results.
Okay.
Yeah.
And we do have one with data.
Yep, here's one with data.
I don't think we have it entered.
We don't. Do you want to make a separate video with the one with data?
Yeah.
Okay.
Let's do that.
All right. So we'll make a separate video for the one with data. We'll enter that. We'll get that data entered and show you how to run that.
Okay.
All right.